Okay, children, it is already 7:30, so we will start even though the rest of them have not come in. Yeah. Okay. There's also another thing that just want to let you all know. We received feedback from some people about students annotating all over the place. Okay, so it is very bad. So because of that, we are told to actually disable the annotation. And then in the event that if any of you would like to share, then I will give you the rights to annotate. Yeah, so it will become like that. Okay, so we'll see how, which means not everybody can actually participate now. Okay, all right, so let's just get started. Okay. All right. So you can see what we have here is today's learning objectives. Today we are doing geometry. So basically we are talking about all the angles, and I hope you all can remember, because I know that at primary 5 you would have learned this towards the end of the year. And some of you in your schools, because of all the other chapters, P5 is usually very heavy, right? So some teachers couldn't finish teaching geometry. So as a result, some schools, actually the four-sided figures, they were being left out until this year. So depending on whether you know or you don't know, so when we look at the questions, we may just do a little bit of revision as well, okay? All right. Okay, let's see. I think we have some other people waiting to come in. Finally, they are here. Okay, so basically what we're doing is some of the geometry questions will involve parallel lines. Okay, so how does parallel lines affect our angles? So basically, there are these three types that we want to talk about. Okay, in terms of parallel lines, okay, imagine let's say I draw a pair of parallel lines. Imagine I draw a pair of parallel lines. Basically, what you must know is if we were to connect using another line, what will happen is this angle and the other angle, these two angles will be known as angles between parallel lines. They will add together to form 180 degrees. Okay, then what about alternate angles? You notice teacher Bern actually wrote here that there's this thing called alternate angles. Okay, alternate angles also has to do with parallel lines. So, okay, maybe I just draw another pair of parallel lines. Okay, for example, we have a pair of parallel lines. And I have another line that cuts across. If it forms something like a Z, okay, this angle and this angle should have the same value, okay, because it forms a Z. Of course, it also means the opposite is also true. That means this line comes down and then it goes to this side. This angle and this angle are also of the same value. All right. And of course, then it links us to our third angle. So just now we were talking about between parallel lines, interior angles, then alternate angles, then corresponding angles. Corresponding angles and alternate angles are very, very similar. Okay. So let me find another place to draw. So again, we have a pair of parallel lines. We can have a line that cuts across. Okay, corresponding angles basically mean if you have one angle here, the other angle that is here will have the same value. Okay, now how do we know that they have the same value? Actually, these are all known as like shortcuts. Okay, if you do the long cut, basically this angle is vertically opposite to this angle, which you already know, right? And then this angle is actually the Z, which is the alternate angle. So they are the same. Yeah. So that's why this angle and this angle actually have the same value. Okay. So basically, these are some of the things that we want to talk about involving parallel lines. Okay, we will get started with our questions then. Okay, so this is our first question. And what we need to know is PQRS is actually a rectangle. So you must know the properties of a rectangle. Basically, what we know is that the corners are all 90 degrees. Next thing they tell us is that PEQ and QFR are straight lines. So these are the so-called PEQ is actually the side of the rectangle. QFR is another side of the rectangle. So obviously it has to be a straight line, yeah? Then angle SEF is 64. So you can actually see it inside the diagram. 64 is here. And QFE is 56, which is over here. We want to find PES. That means this little angle over here. Okay, so to actually solve this question, what we can do is, firstly, we may have to link to our, what you call, triangle. Okay, so you notice this shape over here is a triangle. And this corner, which is the corner of the rectangle, is 90 degrees. So if you know about the sum of the three angles inside a triangle, they must add to 180 degrees. Correct? So if that's the case, then what we can do is this angle, you want to find this angle, we take 180, we minus the 90, we minus the 56, we will get 34. Okay, and once we have this 34, we can solve for the angle that the question is asking for, PES. Okay, because PES, 64 and 34, the three angles all rest on one straight line. And then what do we know about straight lines? All the angles will add together to get us 180 degrees. Which means now if I want to find PES, I take 180, I minus the 64, I minus the 34. And so we have solved that question. Okay, quite easy, yeah? Okay, so now let's go on to question 2. And in question 2, now this time we are looking at just triangles. So what we need to know is basically you have to read the question to figure out what they are trying to tell you, yeah? Okay, Kaiser, you put into the chat you want to actually solve this question. Okay, let me just inform everybody, yeah? Just now those who came early, I told them we actually received feedback that students have been annotating all over the place, and so some people are very upset, and as a result we are told to stop the annotation. Okay, but if we can, we will allow just one person to share at any one time. Okay, so Kaiser, since you would like to solve it, so only Kaiser will solve, yeah? Okay, I think I have just enabled the annotation. Okay, Kaiser, you test whether you are able to write. Okay, all right, so the rest of you do not write. We'll only see Kaiser solving this. So let's see how Kaiser solves. PSQ is supposed to be equal to QSR. Okay, so you saw Kaiser actually marking the two angles over there. Okay, they are supposed to have the same value. All right. Okay, let's see what else. $70 and 39 degrees. Okay, I can see that 70 is the angle on the right side. 39 is the angle on the left side. Okay, and Kaiser is adding the two angles together. So that will be 109 degrees. And then you take 180 and minus 109. Okay, well done. Okay. Why you think Kaiser is doing that? Because this angle, and the whole big angle, the three angles will form the triangle. Correct? So what you do is you take 180 and minus the 109, you will get 71 degrees. That is correct. Okay, so let's see how Kaiser continues, because what we want is one of those angles over there, and both angles are the same. Yes, so you need to take 71 and divide by 2. All right, when you divide by 2, you find that you end up with a decimal. So you may ask yourself, can angles actually have decimals? Yes, of course, angles can have decimals. All right, so long as you have numbers, why not, right? You can have fractions also. Okay, so there's nothing wrong with angles having decimals, huh? All right, okay, so that angle you divide by 2 is 35.5. That is correct. Okay, so from there, look at how Kaiser continues. So now Kaiser is solving for this triangle, right? Just this triangle itself. Okay, so already we have two angles there. One is 39, one is 35.5. So the third angle, you take 180, you minus these two, you will get 105.5 degrees. Okay, all right, well done. Okay, Kaiser is correct. Good job. Okay, so far I think this shouldn't be a problem, and I don't think we will invite complaints since it is only one person solving, right? Okay, so let's keep it that way, yeah? Okay, now let's move on to our next question. This time we have a square, okay? And of course, when you read the question, it will tell you what you need, what is given to you. PQ equals to PV. So normally what we do is when you see it like that, right, you will want to do the marking, okay? So if you do the marking, it looks like this. Okay, this is known as a marking. Okay, and we normally mark on our figure so that it helps us identify what sort of shape. So it is isosceles. Okay, now do we have anyone else who volunteers? Okay, let's just have one person doing. We don't want to create problems, right? Okay, Hannah Sim. Yes, Hannah. Okay, Hannah, I believe you are able to annotate. So Kaiser, don't annotate anymore, yeah? We let Hannah annotate. Okay, let's see. 90 degrees minus 23. Okay, I can tell where she's coming from. She's talking about the corner of the square. Correct? Okay, yes. So the corner of the square, you notice she now marks that angle. That is 67. Because 67 plus 23 will get you your 90 degrees, which is the corner. All right, very good. Okay, let's see how else. So 180 minus 67. Times 2. Okay, why, Hannah, times 2? Because isosceles triangles have two angles that have the same value. Okay, so how you tell is you actually look at the marking. So the marking actually tells you that this angle here must also be 67. All right, so that's why she takes 180 and minus the 267s. She gets 46, which is actually what the question is solving, is asking for. Very good. Okay. All right. Okay, well done, Hannah. Good job. Okay, children, just to let you know, because you all are still in primary school, right? We actually allow you all to write your equations like that without any referencing. But the thing is, when you do not have referencing, right? If it is if your equation is correct, but you didn't reference onto the diagram, right? Or you didn't write what exactly it is, then you may not get any marks if your final answer is wrong. Okay, so what is the meaning of referencing? For example, let's say the very first equation, Hannah wants to tell us that it's 67, right? So we must know exactly where 67 is, isn't it? It is actually over at this corner here. So it is actually like what? V, Q, P, right? So if you actually write angle V, Q, P equals, now this is considered referencing. Because why? We now know where your 90 minus 23 equals to 67 is all about. So if let's say this is the part that gives you a method mark, right? You will earn your method mark already. Okay.